Hello, my name is Arthur, and good afternoon. Today we're gonna discuss this paper about probability and statistic, and I'm gonna discuss from question one and two.
Hello, my name is Jason, and I'm gonna discuss from question number 3 to question number 5.
Hello, my name is Hansen, and I'm from 11B, and I'm going to explain from question number 6 to question number 7.
Okay, so now I'm gonna explain number one. So it states that for n values of the variable x, it is given that sigma x minus 200 equals to 446, and sigma x equals to 6846. So find the value of n. So this question is about coding. So sigma x minus 200 equals to 446. It means that for each value of x, so this is just for example. For example, if the value of x is 201, and this is like the probability, and this is like 202, 203. So when it says that it's subtracted by 200, so the new table becomes x 1, 2, 3 because the 200 is subtracted. So the sum becomes 400, 446. But sorry, this is supposed to be the frequency. Okay, so it means that the sum of the x minus the sum of the 200, so it means that how many 200 equals to 446. So we're supposed to find how many 200s are used in order to subtract all the x's. So it says that there are n amount of x, so it means that there's also n amount of 200. So 6,846 minus 200n equals to 446. If we calculate that, we will get the value, which is n equals to 32. Okay, so for number 2, a fair six-sided die has the numbers 1, 2, 2, 3, 3, 3 on its faces. The die is rolled twice. The random variable x denotes the sum of the two numbers obtained. So A, draw up the probability distribution table for x. So first, we need to find the possible outcomes of x. So the lowest sum that we can get is 2, and then the maximum is 6. So we can write px equals to 2, 3, 4, 5, and 6. And then first, we need to find the probability of getting the score 2. So in order to get the sum, which is 2, we need to roll 1 and 1. And as we see here, there's only 1, 1. So the probability of getting the score 1 and then 1 is 1 over 6 times 1 over 6, which equals to 1 over 36. And then to get the sum, which is 3, we can either get 1, 2 or 2, 1. And to get the score 2, the probability is 2 over 6 because there are two values of 2, and then the total is 6. So the formula is 1 over 6 times 2 over 6. But we can also get it in reverse, like 1, 2, and then 2, 1. So we need to times it by 2. So it will equal to 1 over 18. So for the sum to be 4, well, the others we can get is 2, 2, 3, 1, and 1, 3. So for 2, 2, the probability is 2 over 6 times 2 over 6. And then for 3, 1, and 1, 3, it's the same as the above, but there are three values of 3. So the probability is 3 over 6 times 1 over 6. And then don't forget to times it by 2. So it will equal to 10 over 36. And then for the... Oh no, wait. No, not yet, not yet. Okay, so for the score to be x equals to 5, we can get 3, 2 or 2, 3. So we can just get the probability of 3, which is 3 over 6, and then the probability of 2, which is 2 over 6. And then times it by 2 because the order can be reversed. So equal to 12 over 36. And then for x equals to 6, we need to get 3 on both rows. So it's 3 over 6 times 3 over 6. So it equals to 1 over 4. So this is the probability distribution table. Alright, next. Okay, so find expectation x and variance x. So expectation is the mean, so it means that the formula is sigma x times the probability. So scroll a bit to the table. No, just to the table. Only the table. Okay, so as we can see here, to get the x2, the probability is 1 over 36. Then for us to score 3, the probability is 1 over 18. So we can just times the x with the probability of h. So this is the equation. Then the answer that we will get is 14 over 3 or 4.67. And now we need to find the variance. So the formula to variance is sigma x squared times probability minus the expectation x squared. So we can just use this value squared. And for this one, we can just do the same formula but with the square. So yeah, this one should include the square. So it will equal to 10 over 9. And now Quezon will explain the other numbers.
Okay, so number 3, the back-to-back stem and leaf diagram shows the diameter in centimeter of 19 cylindrical pipes produced by each of two companies A and B. Find the median and interquartile range of the pipes produced by company A. So for the position of median, it can be found by using the formula n plus 1 over 2. N is the number of datas, so 19 plus 1 over 2 is 10, and in 10 it is this one. It is 0.355 centimeters. For the interquartile range, it is Q3 minus Q1. To find Q3, it is 3 over 4 times n, which is 14.25, but we rounded up to 15. And the 15th place is this one, 0.366. For quartile 1, it's 1 over 4 times 19, which is 4.75. And we round up to 5, and it is 0.348. This one. So interquartile range is Q3 minus Q1, which is 0.018. Next, it is given that for the pipes produced by company B, the lower quartile, median, and upper quartile are 0.346 centimeter, 0.352 centimeter, and 0.37 centimeter respectively. Draw box and whiskers plots for companies A and B on the grid below. So for company A, we can use the data from the one that we have found just now with this as the lowest data. This is Q1, this is median, and this is Q3, and this is the highest data. For company B, it is given that this is the lowest data, and this is the highest data. For Q1 of company B, it is 0.346. For the median, it is 0.352, and quartile 3 is 0.370. Okay. C. Make one comparison between the diameters of the pipes produced by companies A and B. From the box and whiskers plots, we can see that the data of diameters of the pipes produced by company B is more spread than company A. Okay, next question. Question number 4. The weights in kilogram of bags of rice produced by Anders have the distribution and median is 2.02 and the variance is 0.03 square. By Anders weighs between 1.98 and 2.03. So we can see that the normal distribution is this, and what we need to find is this. To convert x to z, we use the formula x minus mean over variance, over standard deviation, and we calculate, and this is what we need to find. So from the table, we find 0.333, which is this, and negative 1.333, so 1 minus 1.333 in the table, and the answer is 0.5391. Okay, next. The weights of bags of rice produced by binders are normally distributed with mean 2.55 kg and standard deviation kilograms. In a random sample of 5,000 of these bags, 134 weighed more than 2.6 kilograms. Find the value of standard deviation. Okay. So from this statement, we can see that x and this one, and the probability x is greater than 2.6 is 134 over 5,000. So this is 0.0268, and to find the z, we need to find it from the table, but in the table there is no 0.0268. So we need to 268, which is 0.9732. So z equals 1.93. So we can substitute it now to the formula, which is z equals x minus mean over variance, standard deviation, and with that we can find the standard variation, which is 0.0259. Next, in a large college, 28% of the students do not play any musical instrument. 52% play exactly one musical instrument, and the remainder play 2 or more musical instruments. A random sample of 12 students from the college is chosen. Find the probability that more than 9 of these students play at least one musical instrument. So this is binomial distribution. So to find the students, that play at least one musical instrument is 1 minus 28, 0.28, so it is 0.72. and it is probability x is greater than 9. This is probability x equals to 10 plus probability x equals to 11 plus probability x equals to 12. And then we can get the answer 0.304. Next, a random sample of 90 students from the college is now chosen. Use an approximation to find the probability that fewer than 40 of these students play exactly one musical instrument. So for students that play exactly one musical instrument, it is 0.52. To find the mean, the formula is n times p, which is 46.8. To find variance, the formula is n To find variance, the formula is n times p times q, which is 22.464. So this is now the normal distribution. So we need to find the probability x is less than 40. We can substitute it to the formula x minus mean over standard deviation. So it is probability z is less than negative 1.54. If we draw it, it is like this. So we need to find this area. So it is 1 minus 0.9382, and the answer is 0.0618.
Okay, so hello everyone. Now I'm going to do number 6 to number 7. For number 6, we will be using the factorial. So 9 factorial over 2 factorial times 2 factorial times 2 factorial. Why we will be doing that is because 9 factorial is the number of arrangements that we can make from the letters crocodile. And the 2 factorial over here, it just represents the repetition of letters. Because C, there are 2 letters, and O has 2 letters which are just the same. So we have to divide it by 2 factorial times 2 factorial. Then for letter B, find the number of different arrangements of the 9 letters in the word crocodile in which there is a C at each end and the 2 O's are not together. So for this question, I prefer to do one of the solutions. So the C's, I will not look at it first because it's just at the end and it's just 1, because you cannot move it, it's just there, constant. But for the 2 O's are not together, I will be using another solution. So first I will write down the letters that will be like not in the condition of the 2 O's are not together. So it will be R, D, I, I, L, E. And from over here, we can see that there are like 5 letters, And then there is always a gap in between those letters. But always remember to put a gap before the first letter that you want to use. Let's say the R here, there must be a gap here. This gap here. And also always at the end there must be also a gap here. And from there we can find the O's, how many ways the O's can be arranged. Because over here there is still let's count the number of gaps first. 1, 2, 3, 4, 5, 6. This shows that how many O's can be inside the gap. I mean, how many different gaps the O's can be inside. So the first one, let's say O, it can be into 6 gaps. That's why there's the 6 here. And then the second O, it only has 5 gaps left to go to. So that's why it only has, there is the 5 here. Over the 2 factorial, because while the O's are still same, so we have to divide 2 factorial also. And the 5 factorial over here is just the R, D, I, L, E, how we can change the position of it. For letter C, 4 letters are selected from the 9 letters in the word crocodile. Find the number of selections in which the number of C's is not the same as the number of O's. So the first keyword over here is the selections. And the condition is that the number of C's is not the same as the number of O's. The first one is there's a O at the first gap. Well, of course, I try to make the gap first. Then try to draw the gap first. Then after that, I will put the number of the letters. Then for the second one, the C is at the first gap. The third one, the O and O. So I cannot do C and O because then it will make the number of C and the number of O's the same. And for the fourth one, it's the same like the O's. Fifth, CCO, and the last one OOC. Because we want to find the number of selections, we don't need to know the arrangement, and we will just use 5 choose 3 or 5 combination 2 like that. And because why we say 5 combination 3, it's because why 5? Because the remaining letters that we will be using from aside from C or O, it's just 5. So because there is 9 letters here, 9 minus 5, minus 4 equals to 5. And why we don't use the C and O? Because we will already put the O and C into different kind of arrangement in the drawing there at the left side there. So that's why we don't need to put the C and O anymore. So for the first one, 5 combination 3. The 3 is the number of gaps remaining. The second one is the same, and the third one is 5 combination 2. Fourth is 5 combination 2, the same. And last, the fifth and the sixth is 5 combination 1 and 5 combination 1. And then we total it because it's an OR. It's different kind of arrangement, so it's an OR. And 10 plus 10, 10 plus 10, all of them, it become only 50 selections. For the last question of number 6, find the number of ways in which the 9 letters in the word crocodile can be divided into 3 groups, each containing 3 letters if the 2 C's must be in different groups. So for the first step, I will always draw the gaps, the 9 letters, the 9 gaps. Then after that, the condition for this one is that the 2 C's must be in different groups. Okay, so the first one, the C is at the first and second box here. And all of them is the same because if we put it into, say, the second box and the third box, it's just the same thing as this one. So because this is just selection, not arrangement, it's just the same thing. And then after that, if we just put it into, let's say, like this, it's also the same thing as like this one over here. So what sets them apart is actually the O's. Why we put the O's together? Because why we put the O's first? Because the O's are like repetition, and in like selection like this, it's difficult for the O's to be then divided by 2. So it's better to just immediately put the O's there to be fixed. So the first one is COO. The O is over here, and then there's the C here. Then there's the CO. And it all just the arrangement is different for the O's, which really makes the difference between the first, second, third, and fourth of this arrangement. And then the O here, and lastly the O here. And we will just count the number of gaps to calculate this. So the first one is 5 choose 2 times 3 choose 3. 5 choose 2, it's because there are 2 gaps on the second box here, and the remaining is 3 choose 3. Don't forget to minus it because it's not returning, it does not return. After you, let's say, take already the 2 letters, then it's gone already, the 2 letters. And then after that, the second one, it's 5 choose 1 times 4 choose 1 over 2 times 3 choose 3. Why do we have to divide it by 2? It's because that so on the bottom of the paper, there is already the note where COL, let's say COL and COI, is the same as the arrangement with COI and COL, or COR COD is the same as COD COR. And because there are like 2 possibilities that are just like the same, we have to divide it by 2 because they're just the same. This is the number of selection, not the number of arrangement. And then after that, for the third one, 5 choose 1, 4 choose 2 times 2 choose 2. It's the same mechanism. 5 choose 1 because the first box, it has only 1 gap left. The second one, 4 choose 2 because there's 2 gaps left and the 1 is already taken, so it's only 4. And the last one is 2 choose 2 because, well, there are only 2 letters left available and 2 gaps available. The last one is 5 choose 2 times 4 choose 2 over 2 times 1 choose 1. And for this one, why it's divided by 2? It's because it's the same reason as why the second one is also divided by 2. Over here, the bottom right, let's say CLR and CDI, it can be changed. They have the same arrangement, and because of that, we have to divide it by 2. Remember, it's just the number of selections, not the number of arrangement. So that's why it should be divided by 2. And then the last one is added up all of them, because this is an OR. The OR is, that means it should be addition. Okay, so for number 7, Hannah buys 12 hollow chocolate eggs that each contain a sweet. The eggs look identical, but Hannah knows that 3 contain a red sweet, 4 contain an orange sweet, and 5 contain a yellow sweet. Each of Hannah's 3 children in turn randomly chooses and eats one of these eggs, keeping the sweet it contains. Find the probability that all 3 eggs chosen contain the same color sweet. So the same color, right? It will be RRR, OOO, YYY. From RRR, it will be, so because this is asking for the probability, over here there is 3 contain a red sweet. So 3 over 12 times, because we already took 1, then it will be just 2 over 11 times 1 over 10, which becomes 1 over 220. Then 4 over 12 times 3 over 11 times 2 over 10 with the same mechanism. And YYY is also the same. 5 contain a yellow sweet, so 5 over 12 times 4 over 11 times 3 over 10, so it becomes 1 over 22. And if we add them all up, it will be just 3 over 44. Next is B. Find the probability that 3 eggs chosen contain a yellow sweet, given that all 3 children have the same color sweet. It's important over here to remember that it's given that. When given that, we use the symbol. So it's like a division sign. So P, Y, 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 and children with same color, which is technically just Y, right? Over the same color. So we can already find this information from the previous question. Y, Y, Y and same color is over here. Because Y, Y, Y and same color is just technically Y, 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 right? So then we already found that it's 1 over 22. And then after that, the same color we found already, it's over 3 over 44 here. So if we add them up, not add them up, if we calculate it, it will become 2 over 3. Then for letter C, find the probability that at least one of Hannah's 3 children chooses an egg that contains an orange sweet. So I prefer the easier one, the easier solution. There are a few solutions, but I prefer the easier one. So we can just use 1 minus probability of no orange. The orange there is no orange, that means it's only OOO and YYY. And, oh wait, no, RRR and YYY. So there is 3 and 5. So there is 8 sweets that are not orange. So 8 over 12. And then 7 over 12, because there are 3 children, they take 1 by 1, right? Times 6 over 10. But remember that we have to do the 1 minus the P no orange, so that it will become confirmed there's an orange sweet, right? So then the calculation will be 41 over 55. So I think that's all for this paper. I hope you understand. Thank you.